Hello students, welcome back. I hope you've had a very good puja break and you're all ready now to get on with your classes. Today we'll be starting off with a very new chapter from the geography section, that is Unit 3, Rotation and Revolution. From this unit we'll be discussing about 4 different subtopics. Firstly, we have rotation. Secondly, causes of Earth's rotation. Thirdly, revolution, and under which we will be learning about the different seasons caused by the revolution of the Earth. And lastly, about solstices and equinoxes. So let us carry on with the class and learn more about each of these different topics. Have you ever wondered why do we have daytime and nighttime, or what causes day and night, or why the weather conditions keep changing throughout the year? Why do we have summer, rainy, monsoon, autumn season? Why the polar regions always remain very cold and the equatorial regions very hot? All of these differences that take place in terms of weather condition or about the daytime and nighttime, these are all the results of the movement of the earth. The two main movements of the earth are what we understand as rotation and revolution. The earth spins on its axis while orbiting around the sun in an imaginary path. The motion, which involves one complete spin on its axis in 24 hours, is called rotation, whereas the motion of the Earth, which involves one complete orbit around the Sun, is called revolution. As you can see in the picture, rotation means the rotation of the Earth in its own place, and it takes one whole day to rotate on its own. Whereas revolution, as you can see in the picture, means orbiting around the sun. The big circle that you can see, that's where revolution takes place. Rotation takes 1 hour, whereas revolution takes a year. And because of these two movements, it affects the temperature and the weather, and thus we experience the different seasons. Now let us learn more in depth about rotation of the Earth. Rotation of the Earth simply means the rotation of the planet Earth around its own tilted axis. Tilted axis meaning, as you can see in the picture there, North Pole and South Pole, you can see how the line is not straight. It is a little bit crooked, and that is what we understand as tilted axis. The Earth rotates from the west towards the east, meaning that the rotation takes place in an anti-clockwise manner. The Earth's rotation is compared to that of a top which spins at a speed of 1670 km per hour, rotating freely on its own axis. It takes the Earth roughly 24 hours to complete one rotation, meaning it takes a single day and a night. Now, let us find more about the other subtopic, that is the effect of the Earth's rotation. As the Earth rotates on its own axis, the part which faces the Sun experiences daylight, while the part which is away from the Sun is dark, and that is the part which experiences the night. As the Earth is tilted at a certain angle, a part of it comes under a shadow. The shadow falls in such a way that a line seems to separate day from night, as you can see in the picture. A certain line is made which separates the day and night time. That line is what we call it as the line of illumination. The Earth's rotation on its tilted axis causes the sun rays to fall at different angles on its surface. When the sun shines directly overhead or its rays are perpendicular at a particular place, it experiences noon. Noon marks the 12 o'clock in the afternoon. From this position onwards, the rays of the sun begin to get slanted as the earth rotates away from the sun. That is when you experience the evening time. Just as the last rays of the sun fade away below the horizon, there is dusk, meaning slight light when the sun is setting. When the sun sets below the horizon, we experience darkness, which is called night. As the first rays of the sun begin to emerge from beneath the horizon, there is dawn, meaning the beginning of light as the sun rises. As it rises above the horizon, its bright rays bring in the morning and the darkness of the sky vanishes. If the axis was not tilted and perpendicular to the plane of the earth, all parts of the globe would have experienced equal length of day and night throughout the year. But since the Earth's axis is tilted, it causes varying lengths of days and night and different seasons. In summer, days are long and nights are short. Places in the equatorial region like Brazil, Maldives have almost equal days and nights throughout the year because the rays of the sun fall directly here all year round. But as winter approaches, the days begin to get shorter. I'm sure all of you must be experiencing it right now because it's almost November now and the days are getting shorter. During summer, you see that almost like around 6:30 in the evening, it gets dark then. But now by 5:30, you see that it's almost dark. That shows that the winter is here because the days are shorter. As we move away from the equator, the rays of the sun becomes more slant, that is, moving away from the sun, thereby causing greater differences between days and night. During midsummer, the poles, that is, the North Pole and the South Pole, they have 24 hours of daylight, and during midwinter, they have 24 hours of darkness. The Earth's rotation also gives it its geoid shape. That means bulging at the equator and flattened at the poles. In the picture here itself, you can see how the middle part, that is where the equator is, you can see that it is bloated, right? The middle portion, and the top portion, that is the North Pole and the South Pole, it's a little flat. This is because the Earth spins faster at the equator, meaning in the middle portion. Therefore, it causes for it to spread out more, making it look more broadened, okay, like it's bulging. Now, let us learn more about revolution and how it is different from that of rotation. What are its causes? How does it cause different changes in the season? As we discussed earlier about rotation and revolution, here revolution means the motion of the earth as it travels along an imaginary path around the sun is called revolution. You can see a big circle around the sun. That is the imaginary path, and that is where the earth rotates on its own axis, and at the same time it will orbit around the sun, okay, the whole circle. That is what we understand as revolution. One complete revolution of the earth around the sun takes 365 days and 6 hours. One calendar year has 365 days. The 6 extra hours of 4 consecutive years is added to make one full day. This extra day is added to the month of February every 4 years. That particular year has 366 days, and that is what we know as leap year. Thus, in a leap year, February has 29 days. That means after every 4 years, that particular year will have one more day added to it. That is why many of your birthdays may be falling under February 29, making it as a leap year. Throughout the course of its journey around the sun, the earth experiences constantly changing season because as the earth is rotating, it is also orbiting around the sun, making a revolution. The seasons that we experience throughout the year are caused by the earth's revolution and because of the tilted axis of the earth. As the earth travels around the sun on its imaginary path, the side leaning towards it keeps changing. That is, when the northern hemisphere, meaning the northern area, leans towards the sun, it receives more light and heat, making it warmer. And at the very same time, the other side, that is the southern hemisphere, which is tilted away from the sun, gets lesser amount of heat and light, making it colder. The result of this is that the northern hemisphere enjoys summer, and when the northern area is enjoying summer, the other area which is away from the sun experiences the winter season. 6 months later, the position of the earth becomes opposite, and the southern hemisphere now enjoys summer as it's tilted towards the sun, and the northern hemisphere, which was having the summer season, will now have the winter season. Now moving on to the final subtopic, solstices and equinoxes. Let us find out more about it. What is overhead sun? When the sun rays fall perpendicularly on the earth's surface, as you can see in the picture, it is not tilted but it is in an perpendicular state. That is what we term it as overhead sun. The sun is overhead between the Tropic of Cancer and the Tropic of Capricorn, as you can see in the picture, and it crosses the equator twice a year. As the Earth's tilt shifts from the northern hemisphere to the southern hemisphere, during the course of its movement, solstices and equinoxes occur and we experience change in the season. Before we get further into detail about solstices and equinoxes, let us find out its origin. Firstly, we have solstices. The term solstice originates from two Latin words. Sol means sun and sister, which means to stand still. Equinoxes. The term equinox is derived from the Latin word equus, which means equal, and nox, which means night. So now let us dig further into both of this topic. As you can see in the picture, summer solstice occurs around June 21st in the northern hemisphere and marks the longest day of the year. On this day, the sun is overhead at the Tropic of Cancer. As you can see in the picture, how it's facing towards the sun. On the same day, the southern hemisphere experiences winter solstice, marking the shortest day of the year. 6 months later, on December 22nd, the sun is overhead at the Tropic of Capricorn. During this time, the southern hemisphere experiences summer solstice. This day is the longest day in southern hemisphere, while in northern hemisphere it is the shortest day of the year. You can see how it is vice versa. Here towards the left side you can see the June solstice, that is the summer. On the other side, you can see the December solstice. So as the revolution take place, the winter and the summer, it becomes opposite. Whereas you can see during an equinox, days and nights are equal all over the earth. Equinoxes occur twice a year, generally around March 20 and September 22nd, as you can see in the diagram given here in this picture. Spring or vernal equinox occur around March 21 in the northern hemisphere, which marks the beginning of the spring season, where you can see the blooming of the new flowers. On this day, sun rays fall directly on equator, meaning the middle area, and there is equal day and night all over the world. The spring season is followed by the summer. At the same time, the southern hemisphere experiences autumn equinox, which is followed by winter season. Autumn equinox occurs around September 23rd in the northern hemisphere, followed by winter season, and during the same period, southern hemisphere experiences spring equinox, which is followed by summer season, meaning the same season that they experience as the revolution take place, it will be interchanged. Thus, we can conclude saying how revolution of the earth goes different seasons that we have in the year. We have the summer, spring, autumn, and winter season. That's all that we will be learning from this very particular chapter. I hope you have learned something new and now it makes more sense about the different changes because of the movement of the earth. Thank you. Stay safe until we meet again for the next class.